So looking at 4, actually what we can do is this. You guys share a book. Hey, you share a book at your table. And here, and there should be one. So, well, one over here, so you can share a book. So, you'll start by looking at 4, then go 8C, 17, 38, 45. So, okay, we're looking at number 4 for right now. So if you guys are looking at number 4, all right, first thing it asks you to do is it's asking you to look at the graph, all right. If you look at where it says P of -6, P of 2, P of 9, all it's asking you to do is first of all look at the graph, right? P of -6 is on that bottom part of the graph where the arrow is, where the line is a straight horizontal line. So really, I mean, if you look at this, it should be pretty simple to see that what the y value is for that. All right, so 4a says P of -6. If you look at the graph, it's a horizontal line that goes along the y value of y equals -3. So also to confirm that algebraically, you literally have to do nothing, because if you look at it for -6, the equation says P of t equals -3 if t is less than 2. Is -6 less than 2? So P of -6 is -3. All right. So part B. Okay. P of 2. Okay. Again, if you look at that and you look at that graph, you see P of 2 is probably about 1. All right. So what you're going to do to confirm that algebraically, it says that P of t is equal to t minus 1. Don't put your phone. All right. So really, it's equal to 2 minus 1, which is equal to 1. Confirm that algebraically. All right. Part C says P of 9. Again, it is the same equation because for t greater than or equal to 2, it's equal to t minus 1. So 9 minus 1 is equal to 8. Questions about that? Was that cleared up? Yeah, me and mine right there. All right. 8C now. Okay, 8C. says, use the graph to estimate when water consumption was 6 billion gallons. Confirm algebraically. So first of all, if we look at this, it says, well, 6 billion is going to be at 6,000. That's 6,000 million. Remember, we don't speak real words in here. We say 6,000 million. So 6 billion gallons, you go across there and you look and it's like, see 24, but it's a little bit past 24, right? You make a guess or an estimate. So I'm going to guess 25 because it's just a little bit past, and 25 and a half will be like halfway through because the distance is 3. So I'm going to say 25. That'd be my guess. You can make a guess. You can say like 26, or I mean, it doesn't look like 26. 26 would be a little bit closer to 27. So I say 25. So what I do is I'm going to say, okay, my guess is 25, and I'm just going to plug 25 into my equation. And it says the equation is, well, in this case, the f of 25 is equal to 9.35 times 25 squared minus 12.7 times 25 and plus 541.7. Okay, I type that into my calculator. I get 3,027.95 million gallons. Okay, that's more than what are we guessing? Wait, I don't get that. I'll look down to one number. I get You guys aren't going to say anything. 6,067.95 million gallons. Okay, or that's equal to 6.06795 billion. Okay, so that proves that in whatever year that is, year 25, so 97 or 77, 25, 2002, maybe. So in the year 2002, it looks like they're going to have over 6 billion gallons of water, or whatever that is. Questions about that? So again, you just estimate, and then you plug in the number, and straight into the equation. All right, let's make sure we're focused up here right now. So, 17. Don't do it. You're just trying to mess up right now. Alright, so 17 says, that you're using the graph of each function to find its intercept, y-intercept, and zeros and find these values algebraically. So it says 2x cubed, so it gives us the function of 2x cubed minus x squared minus 3x. Alright, so first thing it asks us to do is find our y-intercept. If you look at that graph, alright, on number 17, you'll see that it has a 0 right there, or it has a y-intercept right there in the middle. Hello? Maurice. Counselor needs you, Maurice. Alright, so in order to find the y-intercept, now if you're looking at the graph, you can make a pretty good estimate that the y-intercept is at the origin, which is y equals 0. We have to be able to prove this though. Alright, and so how do we algebraically find the y-intercept? What x value does that have? 0. So I plug in, so really what I need to find is f of 0, which is equal to 2 times 0 cubed minus 0 squared minus 3 times 0. Well, 0 cubed is 0, so that whole thing is 0, minus 0 squared is 0, so that's all 0, minus 0 more, that's equal to 0, so that proves that our y-intercept is at x equals 0, or y equals 0. Alright, so this is our y-intercept. So, y-intercept at, you can write it several ways. It's at the origin 0, 0, alright, or you can write it y equals 0. Okay? Questions about that? That's pretty, remember, find your y-intercept. Graphically, I want you to be able to find it graphically if you see a graph, but I want you to be able to find it algebraically. If you know to substitute 0 in for x, you're good. Alright? Now, to find the zeros, if you look at that graph, you'll see, now the zeros occur where? What are we really trying to find when we're finding those zeros? The x-intercepts. How many x-intercepts are on that graph? Anyone else want to confirm that? 3. Okay. That means we have 3. Now, go ahead, guess, someone guess what they might be. Come on, 2, 0, 3. 2, 0, 3. Are you sure one might not be negative something? Oh, negative. Negative? Alright, shit. So, we have to be able to find this though. Alright, so those are estimates. So, what we do is, first of all, to find our zeros, probably going to have to factor. Okay? Now, right here, this is not a quadratic function, so we cannot factor the normal way yet. Right? It also only has 3 terms. That means we can't factor by grouping. But what we can do is that we can take this and we say 2x cubed minus x squared minus 3x. And look, we're going to set that equal to 0. Now, if we're looking at that, what do all 3 of those terms definitely have in common? X. I'm factoring an X out. Alright, so I'm bringing an X out from here, an X out from here, an X out from here. So that takes me to X times 2X squared minus X minus 3. That's still equal to 0. Now I have a quadratic function. Okay? I like quadratic functions because those are easy to factor. So to factor this, you want to remember what's the first step in factoring this type of quadratic function? Nope. So we're going to multiply A and C, or the leading coefficient and the constant. In this case, 2 and negative 3. What is 2 times negative 3? It's negative 6. So I need to factor the negative 6. The factors of negative 6 are negative 1 and 6, 1 and negative 6. Negative 2 and 3, 2 and 3, negative 3. Okay? I need to find which pair of factors adds up to what number. 1. Negative 1. Alright, be more confident around me. So I have to find out which one adds up to negative 1. Which of these add up to negative 1? 2 and negative 3. Alright? So, what I'm going to do, I still have my X out here. That's not going anywhere. Alright? But here, I have 2X squared plus 2X minus 3X minus 3 equals 0. Okay? So, what I do here, alright, I'm going to go ahead and, right here, I'm going to bracket some of these off. Okay? So I have X times. What is this? What do these two terms right here have in common? 2X squared and 2X. And 1X. 2 and 1X. So I'm taking the 2X out. Alright, so I have X plus 1 still. Now when I'm factoring here, what do I know they're going to be the same about these brackets? They're going to be the same. So what can I factor out of here? Is that an X in it? What do they both have in them? Negative 3. That's going to be X plus 1. Okay? So, I now have this as my factor. X times 2X minus 3 times X plus 1. That is equal to 0. Okay? So I have 3 different factors that are now equal to 0. X is equal to 0. I have 2X minus 3 is equal to 0. And I have X plus 1 is equal to 0. Okay? At this point, here's one of my zeros. We said 0, right? Said that was one of them. Minus 1 from both sides, we get X equals negative 1. Alright, so there's another one of my zeros. Add 3. 2X is equal to 3. Divided by 2, I get X is equal to 3 halves. So there's my 3 zeros. Alright, now we're going to start hustling because I'm only going to bother percent about this from here. Almost ready. There's part, they'll get done. Alright guys? Any questions about this?
Oh, okay.
Questions about that? Again, there's tutoring after school today with me if you need more help. Alright? 2:30 to 3:30. Alright? This is what we're going to do. We're going to pause right now. That way you guys can go